Grandma is still here, keeping the baby happy, so time for another model. This time we will use the method man soap bottle as a study object. This object is featuring really nice transitional surfaces, and it's nice and smooth. So it's perfect to rebuild. In this exercise, we will start again with a scan model. The description is in the download link is in the description, not vice versa. And in this model, how we built this, I will show you how we will actually first start everything by creating surfaces. And then later turn all these surfaces into a solid model. And then continue with solid modeling. The other also very interesting aspect of this model is that you can visualize or demonstrate really well the difference between a model where the surfaces are created using a more smooth or G2 approach, or a model where everything is created out of lines and arcs, so more a tangency model. So what does that mean? If we now rotate our view, you can see how, look, there are edges everywhere. Now, so that's basically a G1 model. And the reason why we have those kind of like edges showing up in the highlights is this is a line to an arc and a line to an arc. And that can only be G1. And even down here, an arc blends to an arc, a line blends to a line, and so forth. And then this blend to this blend can also be only G1. If we now go to the method man here and rotate, you see this is super smooth, really nice. Yeah. Okay, so let's go to a new file. We will go insert mesh. I downloaded the method man. Again, the link is in the description. Open. This mesh was exported from Fusion while the model was using millimeters. So when we import it, it has to be millimeters. So this model is in millimeters actually, not meters. Okay, very good. To verify, we go to the front view, make a sketch, and then draw a line straight up. This should be like 210 millimeters. Okay, we don't need that sketch, so let's delete it. And we will now start with the bottom. So I go to bottom view, sketch, go to here, bottom view, that's good. And I will actually start first by doing this, a line. Hold on, actually, sorry. Let's delete this one more time. A line, and now, and this is important, click and drag into an arc. A line, click and drag, finish the arc. Here we would like this to be connected. Very good. We make this all horizontal. Very nice. These two will be the same. Oh, that can't be equal constraint. Why? Well, because these lines are horizontal, so these arcs will have the same radius, because you see when one moves, the other one moves. Let's dimension everything a little bit. So D, this will be 21. Okay. And then this will be 23. And then we can draw a line there, escape. And on this line, I would like to position a point right at the midpoint. And you might ask yourself, well, what is this point for? Escape, check this out. This point now, I can coincident constraint to there. You see? This way I glued the point onto there, the point was glued onto the line was glued onto these arc points, and because of that, it pulled everything. Very good. Okay, so there we now have kind of like a G1, so a tangency sketch. And I said before, this is not really what we want to work with because it doesn't create very nice and smooth results. But we're going to use this as a reference. So I select all 4 elements, and then line type will be the construction. Because now I can go at fit point from the center to here, to there, midpoint again, to there, midpoint, there, midpoint, somewhere there, and I finish. Cool. So you see this way I use actually the existing sketch as a diameter or width and length sketch. Now what's important is that these points are all at the same position. How can we do this? Easy thing, because this is more of a symmetrical rectangular shape. We will do a lot of horizontal and vertical constraints. So these 2 vertical and then these 2 horizontal. Escape. Now when I move actually this point, you see how all 4 points move. Fantastic. And what I'm looking for is when I move this one up, look, I get a really nice flow here. Okay. But what's happening here? We see this actually, the arc goes, or not the arc, the curve goes over our initial sketch. Let's turn on the curvature display. Maybe let's make this a little bit smaller, and then we can see here the curve direction changes. That is not good. So very gentle, I have to move this one down till at least, like here, this red line is above this point. Because now this is only convex. Here now this surface becomes concave and then it's convex. There. Another very nice feature or way how to use the curvature control. Sorry. Not curvature control, the curvature display. Okay, so this is good. Very nice. Finish sketch. Now we need to have another sketch. So construction. We look at the bottom, so go to here. This is difficult now to select what we want, so I will try to highlight the correct plane, which is the X and Y. This goes up 40 millimeters. On this construction plane, another sketch. We will do exactly the same. Click, click and drag. Click and drag. Make sure this is all tangent. There. Then D for dimension. The radius, 25. Now, instead of dimensioning this length, I would like to dimension the diameter here. So right click. You see we can say make a dimension from the arc center or tangent to the arc. So from there to there. Look, you see? Pretty cool. 90. Maybe redo this one more time. So D for dimension, then right click and set arc tangent. Click, click, up 90. Again, this trick, a line on the midpoint of the line, we position the point, and then the point we consider constraint to the sketch center. There we are. Escape. Triple click, and you can press X actually for the line type to construction, and then fit point from here to there, 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 and back. Okay, so I would like to hide my initial sketch because something actually is off here. You can see how this is not really perfectly centered. So I will delete this and now I can move this away. Ah, this line was not glued onto that endpoint. See, the sketch actually was, the endpoint of that sketch line was white. Let me undo. You see there? It's not black. Now we have a coincident constraint. The reason why I saw that was actually this line was not symmetrical along the y-axis. So in case, in your case, this is all black, then we are good. In my case, it was not. Goodie. Then we do same thing again. Bring those into the position where we would like them, and then horizontal constraint, vertical, horizontal, vertical, very nice. And then click, right click, curvature display. And then we can get this close there. Cool. Okay. Yeah, this looks actually nice. So now we have the bottom sketch and the top sketch. We will now switch to surface. Whoops, wrong file. Extrude. And then this, we extrude 110. I need to show my body. Hide the scan. And there we are. The scan, by the way, is actually deflated. There's no fluid in it, so it's not as straight as I make the model. I'm just only using the scan as a loose reference. Very good. So now we would like to make this transition to down there. And I can go to Loft and then go from there, do a Loft. So profile 1, I would like to do a G2. There's no G2. Why? And that is because we selected the sketch and not the end of that surface. So we can delete this profile, go plus. And now here is actually the trick. When we hold the mouse button and wait, and we get this pop-up. So this is the sketch and this is the surface edge. And there it is. Or if this is too confusing, what we also could do, okay, let's hide this to there. And then we turn this back on. Cool. Okay, so a really nice, beautiful G2 transition. We can extend this a little bit. Yeah, this is all good. Click OK. Very nice. Good. Now we have the midsection. We have the bottom. The bottom we can actually close. So I hide the sketches and then go to the patch command, select this opening, and then simply say OK. You see now, there we closed it. Now it's time to model the top. So we need to put a sketch to there. That means we need to create a construction plane to 205 for the height. Yeah. Then on this construction plane, another sketch. And you guessed it, exactly the same process. I do this again here because it's easier to see. Just two lines. Okay, I can also do this with arcs. Click, click there, click, click there. There are always multiple ways to roam. There we are. Good. So what do we have here? Dimension D. This is 17. And then this is 12.5. Then we have, as always, this line here in between, point at the midpoint. Both points here are black. That means if I move this, yep, it all moves perfectly. Coincident constraint to there. There we are. Awesome. Okay. So the next step actually will be quite interesting. So we close this and then here's our sketch. Now we can go loft. So this profile or edge of that surface to this sketch, which I didn't finish, sorry. We have to put in actually our spline. Sorry for that. My fault. X for construction, fit point from the midpoint to there, midpoint to there, midpoint to there, midpoint to there, and there. Click, 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 click. Escape, so we stop constraining, and then we move this there. Okay, finish sketch. That is beautiful. Now we can do this. So from the surface edge, oh no, to this sketch and G2. Yeah, but how do we, how do we actually, yeah, I'd like to get this down there. You notice there is actually this arcing down. With this, I can do this transition, but how do I get the S curve? Okay, so there is something called directional control. Ah, interesting. Okay. So now here I can control how far this goes down. And then when I click profile 1, okay. So with this direction, basically what it said, instead of just flowing into it, think about this is the sketch, so the curve should flow to it perpendicular. And there we are. Let's take a look. The scan is not 100% clean, so this is all good. I'm using this as a reference. And yeah, when we take a look, this is actually pretty close. But I noticed there are some inaccuracies. So for example, you see here, 3 squares down, there's a dot. 3 squares down. Yeah, this is not where it is. So this direction command I find sometimes very unreliable. You see also here, left and right, the shape is somewhat different. So what can we do now? And this is actually a very old trick one. I don't want to say trick. This is just a common process, to be honest. If I want from this surface, create a transitional surface to here, but it should look like this flows into another surface, well, then I need to build that surface. Okay, so we will delete this. Then we will go to extrude this slightly up, maybe 10 millimeters. And the trick now is we need to figure out, do we want to rotate this? I will keep this maybe at minus 2.5. So a very slight angle, no? All sketches are invisible. And now U to U, G2, G2. Yeah, look at that. 1.5, 1.5. Perfect. Clean. So now I can move this one up the way how I want. So or maybe I keep this at 1. Let's see. What about profile here? Maybe this is going too far. Yeah, here, see, we can shorten this. And then this one we bring up a little bit. Yeah. Yeah, this is better. Okay, cool. Sweet. So you see the angle of this surface defines on how at the end this surface will flow. That means when I double click to here and say -10, so this is really extreme, you see how this changes it. What about 20? There, no? Pretty cool. Okay. Let's verify -2.5. Very good. This surface now we don't need anymore. Right click and remove. Never delete. Delete is really gone forever with the wind. We only want this to be removed. So we can always go back to our surface. This thing here is slightly yellow. What does this actually mean? So the surface is inverted. Think about a piece of paper. You have two sides, or your hand. You have a top and a bottom. When it's silver, that's your upper hand or your outside. And when it's golden, that's your inner hand or your surface inside. You see there it is silver. We can reverse this into the correct orientation. But that adds another feature, and later this will be corrected automatically. So I will keep it at this. Okay, now we would like to dome this. Not only with the patch tool make it flat, but it should slightly go down. How do we do this? Easy. We go to the front, new sketch, click. All these other sketches here hide, and now from this point to there, I don't know, maybe I need to figure something out. So I do S for shortcuts. By the way, I never showed you that before. So when you type in S and then you say pro, look, it finds the command. And you can actually also drag commands in. I have those already in my command bar. So here's project. Maybe I drag this one out. So when I say project, see now this is different. Oh, there I can click and then drag it into the correct order. Okay, or I go to project. Sorry, not project, what I'm talking about. Intersect. I want to intersect this edge because I find these 2 points. Also here, intersect. There. You can find all the commands, pretty cool. It's like an AutoCAD. Well, the software fusion is from Autodesk. They make AutoCAD. Why did I do this? This can actually be quite useful for various points. So now here I have 2 dots. I then can draw myself a line. Very good. And then from this line, there's somewhere a midpoint. There I draw a line down. Select these 2 lines and they should be construction. And then this dimension, maybe 1 millimeter, not very much. So now I've found a point that is exactly centered between these 2 points, and from this edge goes down 1 millimeter. So I have a target. Now I could go ahead and say there are various ways. Let's see, how does loft work? So I would like to loft this to this point. And we need a section view to understand what's happening here. Section view, there, right view, okay. You see now this is actually a straight loft down to the point. It's kind of like a cone, but that's not, we don't want this cone shape. Double click, shape, sharp to point tangent. So how does this look? Let's turn maybe this off. Yeah, this seems to actually work quite nice. I would like to, for the moment, change this there. Very good, because now we can see, there's a little bit of a surface problem. Only because you can do something does not necessarily mean that with the tool you get the surface quality you want. This sounds a little bit cryptic. It's just a piece of advice. Surface tools generate certain types or various degrees of surface quality. Sometimes you can use various tools for the same outcome, sometimes not. So in our case, this is not actually producing what I want. I have a little bit of a surface problem there. So maybe let's delete this. So what else do we have? So we have this patch tool. I can patch this flat. But look at that. We also here have something like a Rails point. Click on that. And on the way, we also can take a look at the zebra stripes. Does it show it? No, it does not. I thought, okay, never mind. Forget this. So that's actually a new feature. They dome this down for us. Patch type trimmed. Yeah, this is all good. So when we delete this, you see it just goes straight down, or we say, hey, patch this to there. How does the section view look here? Looks actually not too bad. It's more linear, and then it domes and then becomes linear. Not as nicely domed all across, but it's 1 millimeter. It's fine. Cool. There we have it. Okay, so now we have everything made out of surfaces. Let's stitch it together. 1, 2, 3, 4, 5. And we have a solid. You see it out there. Solid. Surface model, solid model. Okay. Yeah. We're actually getting close to finish this. We would like to add a few little details. Again, what we're going to do now is also a very nice example for understanding how flexible the timeline is. So I would like to add this element here on top to do this cut. We will ignore the letter M. We will just do a small depression there. When we take a look from here, you can see how this is deeper. So what do we see here? Essentially, this is a main surface, and then we have an offset of that further in. So how do we offset the surface? Well, with the offset command. Okay, well, that's easy. Let's go to offset. There, the surface. Cool. Okay, we can select this and move this down, maybe -1. Good. And now we have this surface, but we have a solid. We need to cut and trim and stitch. That doesn't really work well. Okay, so what do we have to do here? Simply the order we have to change. This feature we delete. And now we go before we do the stitching. And now to the surface -1, we make an offset. Because as you can see now, we see these two surfaces. And to create this ring here, the upper surface, we need to cut the inside, and for the lower surface, we need to remove the outside. So all this we hide. Very good. Where is our construction plane? It's here. From this construction plane, I will make myself a new construction plane 10 millimeters above, so it's a little bit further away. And a new sketch on there. Take a look. Beautiful. And then one ring, next ring. What's actually the distance between these two rings? 1 millimeter. That's very nice. So DD. And what's this diameter? 14 millimeters, 50 D for dimension. Very good. So let's hide this. Number one, number two. I'm hiding all the other stuff. The next step is really important. Upper surface, inner surface. Here we cut the ring or the circular opening. Here we cut everything outside away. How do we do the cut? Look, there's a scissor, trim. Click the inner one and you see how it projects it through. And then I click at the lower surface on the outside. You see it's red. Click OK. And there we have this part left. Now we do this again. This ring. This time we click on the inside. Okay. And we have that gone. Pretty nice, no? And then to fill the gap, we do this via Loft 1, 2. Okay, there we are. Beautiful. So the reason why we have two rings is very simple. By having two different rings, we have two different diameters, and then the loft surface has a nice draft. Okay. Then now we actually can, with Shift, select everything and stitch. Takes a moment. There we are. Beautiful. And the last pieces are the interface elements. So I go to a right view. Oh yeah, we still have this right view section view. If you don't have it, create the section view just for the site. New sketch on this grid. Here actually you can nicely see how the bottle is inflated. And then small ring here, a bigger ring. What's that diameter? 2. Okay. There. This is very suggestive. We only do this basically quickly to add an interface and suggest how something might work. That's all we do. 9.5. Yeah, that looks pretty good. Okay. So you see here we have an opening, and then here we have the hinge. Let's actually go to the hinge element first. So now we switch back to solid, select this ring, extrude this out, but you see that it is cutting. Maybe 9 millimeters, but join please and actually do this symmetrical. Cool, okay. There. We can round this corner a little bit, 0.1. Smooth it out, 0.5. Okay. And on here, there we go with this. And actually there we truly really cut. Also there, symmetrical. I don't know really how much yet. So I'll probably go maybe till there. So -10 maybe. Very good. And I have this edge and this edge. And now I can fillet those. And you see by filleting this, we can round the corner. At one point, we also might get an error warning. So let me hit cancel for the moment and select this ring. And it tells us the radius is 4.75. This is actually really important to know. This is also the radius now here of this ring, 4.75. So when I select these two arcs and say fillet, maximum can only be 4.75. Because then in the end, as you see now, is a sphere. Let me visualize this one more time. actually just here I rip, zip, and zip. Very nice. What do we have? 90.029. See how this at one point will turn into a DOM or an error message. So 90.029. What was this? 90.029. Oh, there's actually 90.029 divided by 2. No. Yeah. It's a little rounding issue. What do you see there? 90. Boom. This is our dome, circular, like it's here. Okay, let's delete this. And then we can verify, is this wide enough? Not yet. So this extrusion can be maybe 10.5. Yeah, this starts to look pretty good. Cool. So we have here the command split body that really slices the element. If we would like to create various materials on various faces, we can actually split a face. And let me show this as the last step. We go back to this sketch here, where we have all this. Take a look here. And then I just draw a line. Careful when you draw a line. Sometimes you can get a little bit of an artifact. I got here. And this line I would like to be horizontal. And since this is a hinge, I will also, from the center of that hinge, draw this line. And here I make this a little bit bigger. Okay. I can stretch this out. Or yeah, it's fine. Actually, I will go back, maybe to prevent for beginners, because when I slice this one in, and later we will go back to editing this feature. You see now these are 2 profiles. This remains 1 profile. Okay, so with these 2 lines, what I can do is now say split face. So this one split by this line. Zack, there. Right click, repeat this face and this, and this. Not this, because that is our hinge. Split by this line. Really good. Now, when this is actually, when I want this line to be kind of like centered on this, this is maybe a tick too high. A little bit lower with M. Yeah, you see now these start to look like 50% pieces. Very good. We could add more details, rounding fillets, filleting edges, so rounding edges, etc. We will not do this because we actually reached the end of what I wanted to show you with this modeling exercise, showing you how beautiful actually the fit point curve works to create nice and smooth forms, and then how we create these transitions and all the other surfaces via the surface commands, and then later finish the model via direct modeling. So here's actually one feature left. This is going to be giving a problem. Oh, it's good this happened. We can delete it. We can hide all this and save this. We're done.